Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. So before starting today's lecture, please do subscribe my channel. My dear students, today we are going to derive the velocity of electron in stationary orbit in Bohr atomic model again. So before starting that, first of all, let's talk about the postulate that has been given by Bohr, and that is the electron will revolve only in stationary orbits. Only in stationary orbits. What are stationary orbits? The orbits whose angular momentum whose angular momentum is quantized is quantized. That is angular momentum. What is angular momentum? It's mv r. The angular momentum mvr must be whole number multiple of h upon 2 pi. The whole number stands for the small n, the orbit number or the whole number multiple of h upon 2 pi. Here we have to evaluate the velocity of electron. Here v is the velocity, so v comes out to be the n h divided by 2 pi m n d r, where r is the radius of the orbit. In the previous lecture, we have just derived the radius of an orbit. The formula for radius of nth orbit is n square h square upon 4 pi square m z e square k. That's the radius of the nth orbit. We have to put the value of this radius over here. So we are putting it over here. So it comes out to be the velocity of electron v comes out to be n h divided by 2 pi m. Now I'm putting down the value, so it comes out to be n square h square divided by 4 pi square m z e square k. Okay, now let's see what's cancelling out over here. Okay, first of all, this pi and the square got cancelled, this m and the m got cancelled. Now this n and the square got cancelled, this h and this square got cancelled. So the velocity comes out to be 4 pi z e square k divided by 2 n h. So this 2 also got cancelled like this, so it comes out to be 2 pi. 2 pi z e square k divided by nh. So that's the formula for the velocity. Again the same way I'm separating the constant and non-constant terms over here. So it comes out to be velocity is z by n. These are not constant terms, the rest are constant, that is 2 e square k divided by h, and pi over here, sorry, it's 2 pi e square k divided by h. These are the non-constant, sorry, these are the constant value. Z by n is not constant, so it signifies that velocity is directly proportional to the z and inversely proportional to the n. That means more the z, more the protons, so more will be the attractive force of nucleus and the electron, so due to which the electron will have the higher velocity in the orbit in which it is revolving. On the other hand, if n, what's n? N is the orbit number. The lesser the orbit number, the electron is more closer towards the nucleus. Hence, again, there are the strong attractive forces between the nucleus and the electron. So, electron will again have the higher velocity. So, now let's talk about the formula. I'm putting the values of all the constant over here. Velocity comes out to be z divided by n. It's 2. What's the value of E? It's 1.6 into 10 to the power minus 19 square. What's the value of K? It's 9 into 10 to the power 9. What's the value of pi? It's 3.14 divided by. What's the value of H? It's Planck's constant, 6.626 into 10 to the power minus 34. So I have just put all the values of constant in my formula. So after evaluating all the values, my velocity comes out to be 2.18 into 10 to the power 6 into z divided by n. So this is the formula for the velocity, and this unit is meters per second. So this is the formula for the velocity of electron in nth orbit. It's 2.18 into 10 to the power 6 into z by n, where z is atomic number, and small n is orbit number. So that's all for today. I hope you easily understood today's lecture. I have just derived the formula for the velocity of electron in nth orbit. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Please don't forget to press the subscribe button. Stay blessed.